electric field, electric field, electric field due to a charged ring, due to a charged ring, charged ring at a distance, at a distance, at a distance, at a distance r r from the center of the ring, from the center of the ring, center of the ring. This question was asked in GGSIP external examination. So this is not in your book. I've not seen this in your. They've asked this thing. So let's do this now. Consider a ring of radius r. Consider a ring of radius r, and the point at which the electric field is required, is at a distance required, is at a distance r. This r, I'm talking about this r. This r, this is r from the center of the ring, from the center of the ring, center of the ring. Now, see the figure. This is your ring. This is of radius r. This radius is r. You need the electric field at this point, at a distance r. Let me write this, not this way. Let me write this way. This at a distance r from the center of the ring. So, due to an elementary portion of the ring, let us consider this much elementary portion of length dl. Consider elementary portion of the ring, elementary portion of the ring, dl, due to which electric field at point P is to be found. Now see the thing. What I want to tell you. Now from here, this is your radius. This is Pythagoras theorem. This is nothing but r square plus r square under root. And the electric field will be directed in this sense. This is the x-axis, or whatever axis you want to take. And this is your y-axis. This is your x-axis and this is your y-axis. Now see, this is making an angle theta here. So this will be angle theta. This is the elementary portion at point P is to be found. And now this elementary ring is subtending an electric field. The elementary ring, let me write it down. This is DE1 due to this part. DE1 due to this part. Let me now show you. Now see this. Now let me write the elementary portion DL. The elementary portion DL gives rise to an electric field DE1 at an angle, vector DE, write it as vector DE at an angle, just a minute, at an angle theta with respect to the horizontal, with respect to the x-axis, with respect to x-axis. No. Now D1 will be resolved into two components, one along the x-axis. Now see, this D1 will have two components. One will be D1 cos theta I cap, and will be dE1 sine theta minus j cap. This will be minus j cap. Because this is the y-axis, positive y-axis is here. So dE1 can be written as dE1 cos theta I cap plus dE2 cos theta, sine theta j2, sine theta minus j cap. This is nothing but dE1 cos theta I cap minus dE2, dE1 it is 1 dE1 sine theta j cap. Now, from the other part, the other part, that is this part I'm talking about, this part. Let me draw it properly here. Now let me take a different color. This will subtend. See, this is a different. This is also angle theta. This is also under root r square plus a square because of Pythagoras. This will give rise to dE2. And this will be theta here. So now this will be dE2 cos theta I cap, and this will be dE2 sine theta j cap. Now from the other part of the ring, the electric field at the point P, the electric field at the point P is dE2, which makes an angle theta with the x-axis, which makes an angle theta with respect to the x-axis. Now dE2 vector is nothing but dE2 cos theta I cap plus dE2 sine theta j cap. Now you can see this here. This is the j cap component, and this is the blue color one I'm talking about. This is the I cap component. So now one more thing. What is dE1? Let us find the dE1 and dE2. They are numerically same, and this is nothing but 1 by 4 pi epsilon naught. Now the elementary charge, that is dq upon r square plus a square. This is the thing where dq is equal to your lambda dl. dq is equal to lambda dl. Now let us see this lambda dl. Yes. Now you can see one thing. Yes, and lambda is charge per unit length, where lambda is charge per unit length. What is the length of the ring? The length of the ring is 2 pi r, the circumference. Length of the ring is 2 pi r, that is the circumference. This is the charge per unit length. You must describe whatever symbols you are using, unit length. This is the charge per unit length, lambda. Now in magnitude they are same. Now what we will do is that let us find the net electric field at point P. Net electric field at point P. Now see, this is nothing but dE equal to dE1 vector in vector form, dE1 plus dE2. No problem about it. Now just put the values of this and the other one. I'm talking about this one. dE1 and this one, dE2. Now see, automatically what will happen is that, see, this is becoming dE. So let us consider this as dE, no problem. If we consider this as dE, no problem, because their magnitude is all same. dE cos theta I cap minus dE sin theta j cap plus, for this it is this much. Now for this dE, it is dE cos theta I cap plus dE sin theta j cap. This is for this much portion because of this. Now automatically, see, either you could have told this way that this component, that is this component and this component cancel each other. You could have written that way also, but it is better you do it vectorally and cancel it. So automatically by this method, these two portions are getting cancelled out undoubtedly. So now dE is nothing but 2dE cos theta I cap. That's it. Now just put the value of dE and everything, and then we'll go for the integration. Now you see, this is dE is equal to 2 into 1 by 4 pi epsilon naught lambda dl upon r square plus a square, and then you have, just a minute, cos theta I cap. Now this cos theta is very simple. If you see this figure, cos theta is nothing but cos theta is this part. This is nothing but base upon hypotenuse. That's all. Just right. Base upon hypotenuse. So dE. So let us put the integration sign now. No problem. Now this will become E equal to 2 by 4 pi epsilon naught. Now this will be lambda. That is lambda. You can take lambda out. This dl. What is cos theta? Cos theta is r upon this r square plus a square, r upon this into this dl upon r square plus a square into I cap. This is the story. Now wait a minute, before I do the integration, I'll tell you what to do. Now this is, now see one thing, E is equal to 2 by 4 by epsilon naught. Lambda I told you is nothing but Q by 2 pi R. Keep this thing in your mind. Let this R come out, because I have to say this R is here. No problem if you don't take it out. R square A square to the power of 3 by 2. Now DL is what? Now this much DL. See, I am talking about this much DL. This is your R, and this is nothing but d theta. So DL, you can write DL as R d theta. You can write this. This is this R radius, because the radius is fixed. This is your DL. This much is your DL. This is your R d theta. So it will become R d theta I cap. No problem. Now the integration is for the whole sphere. So the integration that you need to do is this over, see, it is going to become okay, we are now writing down this one. This is, let us now do the integration. This is from 0 to this is from your 0 to pi. Why? Because if I take 2 pi, it will be double integral, because I've taken the second part also. I'll tell you, wait, I'll explain this. 2 by 4 pi epsilon naught Q. This becomes 2 pi R. This R comes out. This R also comes out. This R square plus A square to the power of 3 by 2 comes out. This d theta is nothing but 2 pi, and this is I cap. D theta integration 0 to pi, 2 pi R cancels out. What you are left with is 2. Yes, you are left with. Wait a minute, so not 2 pi, sorry, it is pi. My integration was wrong. 0 to pi, it will give me pi only. It will give me pi. So this 2 and this 2 pi R will cancel, and you will get is QR upon 4 pi epsilon naught R square plus A square to the power of 3 by 2 I cap, and this will be my electric field. Now see why I said this will be not from why 0 to pi, not 0 to 2 pi. You will say, sir, the ring is of complete circle is 0 to 2 pi. I have taken this much portion, then I have taken this much portion, I have added that, I've taken this half portion and I've taken this half portion. If I go for 0 to 2 pi, it will be double counting of this. It will be a double count. It over count हो जाएगा. इसलिए I have to go for 0 to pi, not 2 pi. Keep this thing in your mind. It will be 0 to pi, not 0 to 2 pi. And that's I wrote pi. I made a mistake writing here 2 pi. That's why I corrected it. So the thing is this, because you are taking this much portion and then again you are taking this much portion. So you are basically taking this. If you take 0 to 2 pi, you will be double counting this portion. Double count. It will be a double count. So that's why you will have to take the integration of theta from 0 to pi only, from this much portion only. From this much portion only. Wait. You have to take only of this, you have to take only this much portion. If you take 0 to 2 pi, it will be a double count. So you have to take 0 to pi. This thing has to be made very clear. At the center of the ring, the electric field R is 0. Therefore, if you put R0 here, the whole thing will become 0. Therefore, E is 0. The electric field is 0. This was a question asked in GGS IPU 2018 or 2019.